Okay, lines, page 9. Um, line L1 has an equation 2x minus y plus 6 equals 0. Write down the gradient of L1. Okay, we can't see the gradient yet because it's in standard form. It's not in gradient intercept form. So let's put it in gradient intercept form first. The way we do that is we get y by itself. So let's add y to both sides. And that will give us y on the right side, and then the left side will have 2x plus 6, and we've already got it in the gradient slope form. So where is the gradient here? It's right there. The gradient is 2. Okay, so the gradient of L1 is 2. Write down the y-intercept of L1. Well, where is the y-intercept? Well, the y-intercept's right there. It's 6. The point A, which is c comma 1.5, lies on L1. Find the value of c. Well, since we have an equation already for the line, the first thing we're going to do is we're going to enter the equation into the calculator and graph it, because we can always get good information doing that. So we'll put y equals 2x plus 6. And then we're going to graph it. And then what it says is it wants to know when y equals 1.5. So let's use the table to do that. When is y equal to 1.5? And we were jumping by 0.3 before, so that's kind of like a weird number. So let's go back and change our jumping. We'll do the second table set command, second table set, which is that one. And we'll say the table start should be 0 because that's the default value. And delta table, we're just going to put maybe 0.1. Okay, and then we'll graph, and then we'll do second table, and then we're going to see when, let's see, when is it equal to, when is y equal to 0.5? 1.5 actually. So if I put the x jumps to 0.1, then I can pretty much see everything. So when is x equal to, or y equal to 1.5? Looks like it's right there, halfway between negative 2.3 and negative 2.2. So let's fix our jump. Instead of doing by 0.1s, we're going to jump even more to like 0.05. And then, oh, there it is. Look, negative 2.25. So at negative 2.25x, the y value is 1.5. So we just found it here. Negative 2.25. Negative 2.25. Find the value of c. So that's c. The point B, 5 comma t, lies on L1. Find the value of t. So when at x equals 5, what's y equal to? So 5. So we just move the cursor up to 5, and like since it's like maybe it's jumping by too much, let's change the jump to back to 1. Okay, and then we're going to look for, okay, what does y equal when x equals 5? And y is just equal to 16, right? 16. Then they say L2 is parallel to L1. Write down the gradient of L2. Okay, so basically they're just checking to see if you understand that parallel lines all have the same gradient. So if the gradient of L1 is 2 and L2 is parallel, then the gradient of L2 is also 2. Find the equation of L2 if it passes through 0, comma 4. Okay, and so this is like probably the hardest thing you're going to do. You can do this with the calculator, but you might need to make a little drawing. And the other way to do it is with substitution. So I'm going to do it with substitution this time, okay, just to have a change of pace. So if you have y equals mx plus c, that's what you want. You know that the m is 2, so we're going to erase that, and we're going to put 2 in here. Okay, and we don't know what c is yet, but how can we find out what c is? Well, what if we substitute in 0 and 4 in for x and y? Then we'll put 0 here, and we'll put 4 here, and then we'll have 4 equals 2 times 0, which is just 0, plus c, so guess what? C equals 4, okay? So the formula for this line is y equals 2x plus 4. And remember the 0 comma 4, if you graph 0 comma 4, it is on the y-axis. So guess what? That is the y-intercept also. So we know from looking at this that the y-intercept is 4, so that's another way you could have figured out that c equals 4 for line L2. Okay, number 8, the line L1 joins the points 1, 2 and negative 1, 6. Find the equation of line L1. So remember, all you need to do is go to stat edit, and then put in these 2 points, 1, 2 and negative 1, 6. So 1, 2 and negative 1, 6. And then we're going to do stat, calc, and linreg. And we go down to calculate. And our equation is going to be y equals negative 2x plus 4. Okay. Then it says C is the point 10, negative 16. Decide whether A, B, and C are collinear, giving a reason for your answer. So they're saying the points A, B, and C, are they all on the same line? And so the easiest way to do that is, we already know that A and B are on the same line, so we're going to make an equation, or we're going to put the equation in the calculator, negative 2x plus 4, and then we're just going to check the table and see if the points 10, negative 16 is also on the line. So let's see. And it is, look, 10, negative 16. So yes, it's on the line. So yes, it is. And another way you could check that, it says giving a reason for your answer. Well, if you put 10 in for x and negative 16 in for y, then that kind of proves it. So let's see. That'll be negative 20 plus 4, which is equal to negative 16. So that could be your reason, okay? Sometimes the reason, oh, I put it in the calculator and it's there, is not good enough, so, okay? Let's see, 3G number 1. Write the equations of these lines. Okay, now these are kind of tricky because there's a vertical line here and there's a horizontal line here. Horizontal lines, basically the slope is 0. So if you wrote it in slope gradient intercept form, you're going to put 0x plus, and the y-intercept here is 1. So guess what? That's 0. So the equation for this line is y equals 1. Okay? And then for this one, it's a vertical line. A vertical line looks totally different than y equals mx plus c. Basically, here y can be anything, right? And x is equal to 3. So basically, if you write that, that's already the equation for the line. X equals 3 defines a vertical line. Okay, it looks totally different because there's an infinite slope, right? Okay. 2a, find the point of intersection of each pair of lines. So you got this line and you got this line, and finding the intersection is one of the easiest things because all you need to do is put it in the calculator, and then we use the second calc intersect function. So we have 3x minus 6 is one of the equations, and the other equation is negative x plus 2, and they already have it in gradient intercept form, so it makes it easier to input these into the calculator. Negative x plus 2. We don't even need to solve for y. Okay, so we graph it, and you'll see that these two lines cross each other at one point. And to find that point, we're going to use the second calc intersect function. So it looks like it's right there. Well, we could even say it looks like 2, 0, but let's check to make sure. We'll do second calc, and then we'll do intersect, which is number 5. And then we'll say, okay, first curve is 3x minus 6. And I only have 2 curves in the calculator, so they're both right. Negative x plus 2, second curve, yes. Okay, and then the guess, and I can move, a little bit toward that, and then I hit enter. And the intersection is 2, 0, and it's exactly where I thought it was, right? So put 2, 0 for this one. Now the second one's a little more difficult because they're not ready to put in the calculator yet. To put it in the calculator, we need to solve for y. So we're going to have 5x 5y equals x, and then we divide both sides by 5, and we're going to have y equals x divided by 5. And then the other one, let's see, we go y equals negative 1/5 x plus 2. And so now it's ready to put in the calculator. We're going to put both of these in the calculator now. Y equals, and the first one is going to be x divided by 5. And the second one is going to be negative, we could put parentheses, 1 divided by 5, and 1 divided by 5 is 0.2, and so you could put that too. X plus 2. And then we're going to graph it, and we're going to intersect them. So there's one of the lines. And then the other line, okay, it's going to intersect right about there. And then we're going to do second calc intersect to find that intersection. So second calc intersect, which is 5. And then the first curve, x divided by 5, yes. Second curve, negative 1/5 x plus 2, yes. Guess, it doesn't really matter what you put because there's only one intersection. If there's more than one intersection, it matters what your guess is because they'll always try to find the intersection closest to your guess. So the intersection is 5, 1. Okay, and that's it for this page.